Okay, this is question 15 in your book for section 4.4. It says rectangle A and rectangle B have the same perimeters. Rectangle A has a width of 1.5d minus 2 and a length of 0.7d plus 1. Rectangle B has a length of 2.5 plus d and a width of 4 minus 1.3d. So because the perimeter of A is equal to the perimeter of B, that's the first thing it tells us. It says, what are the dimensions of each rectangle? So here's what I'm going to do. The perimeter of this will be 1.5d minus 2, because that's what over here, and there's two of those. This one over here is also 1.5d minus 2. So you can either write it as the addition of two binomials, or if you use your brain power and say, well, hold on, that's just the same thing as taking that 1.5d, and because there's two of them, I'm going to multiply 1.5d minus 2 by 2, because there's two widths, not one of them. And there's two lengths as well. So there's two of these 0.7d plus 1s. So that expression is actually the perimeter of A. And I got to move this because it's going to be a giant question. I'm going to group this up together. I'm going to shrink it down so I can squeeze it in here. And then we're going to have some more space to write. So that's going to be equal to, and I have to go backwards. No, you know what? I'm not going to go backwards. I'm going to just take it and put it over here. That's smart. Just bring it over here. So that's going to be equal to the perimeter of rectangle B. And again, it has two of these lengths, so it has two of the 2.5 plus d lengths, and it has two of the 4 minus 4, that's the worst 4 ever, 4 minus 1.3d width. So this really long, complex-looking equation is showing that the perimeter of rectangle A and the rectangle B are equal. So here's what we got to do. We got to simplify this using four little groups of distributive property. There's one there, one over here, and one over here. So we're going to simplify all of these to make this into real numbers. Two 1.5d's is 3d. Two negative 2's is negative 4. 2 times 0.7 is going to be a positive 1.4d, and 2 times 1 is a positive 2. I'm going to use blue for the other side just because I can. Two 2.5's is 5, and 2 d's are plus 2d. 2 4's is going to be a plus 8, and 2 negative 1.3d's is going to be negative 2.6d's. So the green, which was the complex expressions that represented the perimeter of each, have now become the red and the blue. Now if I look at the red side, I notice that it's a polynomial with 4 terms, but there are terms that are like terms, so I can actually add those together. So the 3d and the 1.4d can become a 4.4d. The negative 2 and the positive, negative 4 and the positive 2 become a negative 2. So that left-hand side's perimeter, this triangle, is really the perimeter is 4.4d, that's the perimeter, minus 2, that's the distance around this whole rectangle. That's going to be equal to, gather like terms over here. Actually, hold on, I'm not going to gather my constant first, I'm going to gather my higher degree terms. So 2d and negative 2.6d is going to be a negative 0.6d when I gather the like terms. And then the constant of 5 and 8 is going to become a positive 13. So the perimeter of this one is going to be a negative 0.6d plus 13. Now I was told in the very first part of the question that those two perimeters are equal, so that's why we have the equal sign on both sides. I'm now going to isolate by getting rid of the variable on one side. In this case, I want to get rid of that 0.6d by adding its opposite. I now have 5d minus 2 is equal to 13. Oh, this is looking beautiful. Add 2 to both sides. 5d equals 15. Divide both sides by 5, and d will equal 3. Now, we're not done yet. We're not done yet because that's not what the question said. It says, what are the dimensions of each rectangle? Well, now we know what D is. D is 3. So I'm going to start with rectangle A here, and it says 1.5D. So instead of 1.5D, I'm going to put 1.5 times 3 because that's what D is. And 1.5 times 3 is 4.5, and 4.5 minus 2 is 2.5. So this width, when I substitute the value of D in there, is going to become 2.5. And with 0.7D, if D is 3 again, so 0.7 multiplied by the value of D, which is 3, that's 2.1. 2.1 plus the constant of 1 is going to make this dimension 3.1. So the dimensions of rectangle A are a length of 3.1 and a width of 2.5. Again, take this 3 for the second one, substitute it there. 2.5 plus 3 makes this longer one's length 5.5. And if I substitute the D here for 3, this is a little bit more complicated. Put the D there. That's going to be 4 take away 3.9, which makes the width just 0.1. I believe. Is that right? Did I do that right? 0.1. Now, double check our answers. Since both perimeters were the same, 5.5 and 1.1 is 5.6. If I double that, that's 11.2 as a perimeter. Add up this. 2.5 and 5.6 is 2.3 is 5.6. 5.6 doubled. It also has a perimeter of 11.2. So it's true. The dimensions of both those rectangles, A is 3.1 and 2.5, and B is 5.5 and 0.1.